This video is an example of how to use implicit differentiation with other types of functions. Example, we're going to find dy dx for the secant of y plus e to the x plus y equals 5x. The first thing you need to do, as always, is rewrite the whole equation. Secant of y plus e to the x plus y equals 5x. We're going to put brackets around the whole equation and indicate that we are taking a derivative by writing d over dx out front. The next thing you need to consider is P, Q, C, which stands for product, quotient, chain. I see some chain rules. This is the secant of y, that's a chain. And this is e to the x plus y, the power of x plus y. That's going to be a chain rule right there. Now we're going to take a derivative of each term. The derivative rule for the secant function is secant tangent, the inside y stays the same, times the derivative of y, dy dx. This is all going to be one term. Plus the derivative rule for the exponential function is the function stays the same, e to the power of x plus y, times the derivative of the exponent. In this case, the derivative of the exponent is 1 plus dy dx. All of this equals the derivative of 5x, which is 5. At this stage, I have 3 terms, but there's some factoring going on here. So in order to solve for dy dx, I'm going to need to distribute e to the x plus y. The next line of my solution is secant of y, tangent of y, dy dx, plus I'm going to distribute e to the x plus y to each of these terms. I've got e to the x plus y times 1, e to the x plus y, plus e to the x plus y, dy dx, which equals 5. At this stage, I have 1, 2, 3, 4 terms, 2 of which have dy dx, 2 of which do not. I'm going to move the terms that do not have dy dx to the right side of the equal sign, and I'm going to allow those with dy dx to stay here. Subtracting e to the power of x plus y from both sides. Leaves us with secant of y, tangent of y, dy dx, plus e to the power of x plus y, dy dx, which equals 5 minus e to the power of x plus y. Finally, we can do GCF factoring, leaving me with dy dx times secant of y, tangent of y, plus e to the x plus y, which equals 5 minus e to the x plus y. Finally, we're going to divide both sides of the equation by all of this. So now we've divided both sides by everything other than dy dx. These terms cancel out, and dy dx equals 5 minus e to the power of x plus y over secant of y, tangent of y, plus e to the power of x plus y. And that is the answer. Now, you try. Find dy dx for each of the following curves. At this point, you should pause the video and try to work out the problems for yourself. At this point, you have paused the video. You have worked out dy dx for each of the two problems, and I'm about to display the solutions. Here are the solutions for questions 1 and 2. Thank you for watching.